this is M10Q1, and it's asking about how to combine two admissible heuristics into one such that it's still admissible. So the key point is writing down the definition of admissibility. So it's H3 for any n should be between 0 and H star of n. So the information we know is H1 and H2. They both satisfy this condition. And in particular, H1 and H2 can both be 0, or they can both be H star, or one of them can be H star and the other one can be 0 or anything in between. So the key points are we should have this less than or equal to both H1 of n and H2 of n. So if you look at expression like this, it can be used to eliminate most of the choices. Let's look at the first one. The first one, when you have a subtraction in between, then obviously no, because the first one can be 0, the second one can be 1, so it gets to -1 and it's less than 0. So that one is no. And the second one is a bit tricky, and the counterexample is, say, H1, suppose it's equal to H star and is equal to 0.25, and H2 is 0. So H2 is still admissible. Then it implies H3 is 0.5. Square root of 0.25 is 0.5, and this is actually larger than 0.25, which is our H star, and this violates this condition here. So not the second one as well. The third one obviously is, because we know H2 is admissible already, so that one is yes. And the next one, there is a simple counterexample as well. So it's basically about thinking of counterexamples. H1, H2, H star, they're all 1. Then the sum is 2, and 2 is strictly larger than 1. So this is not going to work. So the last one is a bit tricky. But as I said, we can use our inequality here. Let's put this thing in here. So the max of the two, if both of them are larger than 0, then the max of these two must be larger than 0 as well. And if both of them are less than H star, then the max of these two, in particular, the max between H1 and H2 must be less than or equal to H1 and also less than or equal to H2. And both of them are smaller or equal to H star, so the max must be smaller or equal to H star. So in that case, that the resulting H3 is admissible as well.